as we look at lesson 8.3, accumulation functions in applied context. Now, I don't know if this reminder up top is for me or for you or both. You know, we can say it's for you, but in all honesty, it's for me at times too. And that is if you're trying to find a total amount and you're given a rate. My reminder is if you want that amount, you're going to integrate the rate. Okay? Just kind of, you know, that's how the idea, because this integration is finding the accumulation. So that's finding the accumulation over that time period. Okay? So, accumulation functions. As I said, some of this we're doing the math. Some of this is we're putting it in words. So, get your brains on. We're going to have to put some of this in words. Okay. The velocity of an object in motion is not only the rate that we can integrate to get an amount. We have seen that accumulation or net change problems present us with a scenario where we are often asked to calculate the value of some quantity accumulated over time. We can solve the problem using definite integrals. Now, as we look at example 1, you received a 10-week-old Basset Hound puppy for your birthday and discovered that he is gaining weight at a rate of e to the 125 10,000ths t pounds per week, where t is the puppy's age in weeks. At 10 weeks, the puppy initially weighed 14 pounds. What is the expected weight of your new puppy at the end of week 15? Okay, well, we have the happy little calculator symbol over here, right? So that's good news, which with that E value there, we're going to need to. Any thoughts of how we're going to find the weight of our new puppy at the end of week 15?
Integrate the E to the something T equation and plug in 15.
Integrate the rate, yes. What interval are we going to integrate this at over?
10 to 15.
10 to 15? Because we have 10 weeks is kind of our starting point, yes? And here's the deal. Did the puppy weigh 0 pounds at birth? No. So you can't go with the initial being 0. Okay? But the idea that, so we're going to integrate that rate over the course of the period that he's accumulating weight, which is the 10 to 15 pounds, with the idea that the initial was 14. So basically what we're looking at, I'm going to write this as we're going to do the initial weight plus the accumulated weight. Okay, so kind of some of those calc words that we talk about. The initial weight is the weight of what? That's the 14 pounds, right? Plus, now, accumulated weight. What weight are we accumulating?
10 to 15 E to the
Okay, so we're doing the integral from 10 weeks to 15 weeks of that rate, e to the 0.0125t dt. Okay.
plug in.
It's your job now. This is not something that we're going to do by hand and then plug it all in by hand, because that would just be ugly. Augie says 19.847 pounds.
Yep.
What's the other option you could give?
LBS.
I was talking about 19.846. I agree you could do LBS. That's actually what I have written in my notes, but I don't know why LBS always looks so weird to me. Okay, so the idea that the integral was the 5.0 847, whatever the rest of it was. Okay. Easy enough? Okay, that's the idea of how we can use an integral with accumulation. Let's look at number 2. An electric monorail transport is slowing down at a rate of 2t plus 25 feet per second, where t is the time in seconds. By how many feet per second does the monorail slow down between 1 and 5 seconds?
So the integral of 2t plus 25 will get us the velocity, which is what we want. It's let's feet per second for the time. 1 5. Now initial, I don't.
You don't have to have an initial necessarily. And there isn't an initial.
Perfect.
You were looking for one though, obviously, but okay, so yeah, we just have this rate, it's slowing down, okay? Notice, yeah, the rate it's slowing down, that's feet per second, so that's the acceleration. And then it's asking us by how many feet per second does it slow down. So it's asking us for velocity, so that is an integral. And again, you're looking at the total here. So, now, technically, there's no calculator symbol on this one. However, the math is very doable. Okay. What's the integral of 2t?
2 squared plus 25t plus c.
T squared plus 25t, evaluated from 1 to 5.
We don't need to see.
We don't need a c because
There's no initial.
we have the values. You have an option. You either put a plus c, or you evaluate between values. We have values, so we don't do the plus c. Okay? So this means we're going to do what? 5 squared plus 25 times 5 minus the quantity 1 squared plus 25 times 1.
150 minus 26. 124. Jeez.
I'm with you.
124 feet per second.
Okay. Are we good with that one? Moving along.
Okay.
The number of liters of oil in a tank is changing at a rate of R of t equals 0.26 t liters per minute, where t is the time in minutes. Initially, the tank contained 14 liters of oil. Write an expression that can be used to find the amount of oil in the tank after 10 minutes.
Okay. 14 plus whatever 0, 10, 0.26.
Okay, so you guys noted that there was an initial amount. So we are going to have initial plus accumulation, so 14 plus. Then we were given a rate. So we're going to be integrating the rate of 0.26 t. Don't forget your dt then, with respect to t. And the amount of oil in the tank after 10 minutes, so that's just from 0 to 10. Now, officially, if you ask me, and I go farther, so it must be in the notes that way, but officially, what did it ask? Did we write an expression?
Yeah.
We wrote an expression.
What done?
We're done, technically. Okay. I mean, it's not hard to proceed, especially because there's a 0 and stuff in there, but officially, it does say write an expression, so officially, you get to stop. Okay? Okay, you got your words ready?
Huh?
Your words. Describe. Okay, I'm going to be looking for words.
Oh.
Describe the meaning of each expression in context to the given scenario. The function W of t gives the number of water bottles produced by a manufacturer by time t in hours on any given day. Explain the meaning of the expression.
The amount of water bottles produced from 4 t equals 4 to t equals 8.
Yes.
And what are 4 and 8 besides
Hours.
time? Hours, right? Okay. So yeah, mine reads the number of water bottles produced by a manufacturer during the 4th through 8th hours. Okay, so make sure you get in that label that it's the 4 and 8 are in terms of hours, right? But other than that, yes. Okay. The number of water bottles, gosh, I can't, produced I'm just going to say during the 4th through 8th hours. Or you could say between hour, the 4th and 8th hour. Okay, B, the amount of oil being drained from your pickup truck is decreasing at a rate of R of t quarts per minute, where t is the time in minutes. What does the expression below mean? The integral from 3 to 4 of R of t dt equals negative 0.5.
The pickup truck lost 0.5 quarts between time t equals 3 minutes and t equals 4 minutes.
Basic just makes sense there? Okay, you see the 3 to 4 representing the time interval of 3 to 4 minutes. R of t represents the rate that it's decreasing. Notice it's a negative 0.5, and so that's just indicating that we lost 1/2 quart of oil. Okay, so yeah, mine says between 3 and 4 minutes, a 1/2 quart of oil drained from the truck. Same idea, right? Between 3 and 4 minutes, a 1/2 quart of oil drained from the truck. Okay, good. Keep going here. Kevin got a gift of $500 from his grandparents for graduation. He deposited the gift into his college savings account. Kevin's savings grows at a rate of R of t hundreds of dollars each month, where t is the month of the year. What does the expression below mean? We have 5 plus the integral of 1 to 12 of R of t dt equals 24.
Kevin initially had $500, and then after 1 year, he had $24.
And I think it's a good clue. You always want to watch. They kind of clued us off by saying 500 here and then 5 here, didn't they? But always watch for labels. It says R of t is in hundreds of dollars, which the key to note here is that 24 is not $24, but $2,400. Okay? So, yeah. He said after a year, By the end of the 12th month, Kevin's account had a total of $2,400 in it. Okay, so what Tate said is good. You know, there's variations. You don't have to have the exact wording, but you guys have the idea. By the end of the 12th month, Kevin's account had $2,400. Okay, that one went quick. For reference, your first page of homework, your first 5 problems are doing just this.
Yes.
Okay? So, you know, I know you're complaining about 3 pages of notes but 4 pages of homework. Well, there is some good, right?
Yeah.
Some of this is, you know, I'm not saying it's all easy peasy, but some of it is not bad. So, okay, number 5. A city bus is accelerating from 0 to 18 seconds. The data for the acceleration is recorded in the table below. If the velocity at t equals 0 is 6 feet per second, find the approximate velocity at t equals 18 using a trapezoidal sum. I didn't say everything was going to be easy today, did I? Okay. The city bus is accelerating from 0 to 18 seconds. They gave us acceleration, right? Velocity at t equals 0 is 6 feet per second. So what is that? That's saying initial velocity is 6, if you will. Find the approximate velocity at t equals 18 using a trapezoidal sum. Okay, guys. Forget the context of trapezoidal sum. Okay, forget that for a moment. Just looking at the basics, we're trying to find velocity. Velocity is the integral of acceleration. We have an accumulation here, yes? We also have an initial, yes? So think in terms of what we haven't been doing, initial plus accumulation. So, and I'm going to just say, I'm going to write it as this. In order to find the velocity at 18, we're going to do the initial, which is 6, plus the integral of acceleration. Whoops. So the integral of a of t dt from what? From time 0 to 18. That's technically how we'd write it out. Now, here's the deal. We don't have a nice, neat equation to plug in for a of t, do we? Okay, so that's where are we doing the trapezoidal sum? That's where that's going to be the trapezoidal sum, right? Okay, so 6 plus. Carry it down. Don't lose it. Okay, guys. Trapezoidal. What do you remember?
1/2 height times 1/2 times 18 times base 1 plus base 2.
Okay. So generally speaking, for a trapezoid, 1/2 times the height times base 1 plus base 2, yes? Now, we're not just doing one trapezoid. We're doing all the individual trapezoids.
Right.
But if you recall, there was kind of a way we could combine them, right? Now, what do you notice? So 1/2 is 1/2. What do you notice about each of these heights?
3.
Is it consistent all the way through?
Yeah. So 3.
That's good news, right?
Yeah.
So, because if it wasn't consistent all the way through, we'd have to do all the individual trapezoids. Now, so on the first trapezoid, do you remember how this works?
Oh, you just use.
You have sides of what? 1 and 4. The next trapezoid is going to be 4 and 6. 6 and 8. Everything twice except the 1 and the 10. That sounds familiar, right? See, you know something. So 1 plus 2 times 4 plus 2 times 6 plus 2 times 8 plus 2 times 7 plus 2 times 9 plus 10. Nothing says you can't use a calculator if you know. I know it's 6 plus something.
37, 51, 79. 6 plus 79.
It is.
Nice.
Oh, wait.
No, it's not. I didn't do 1/2 times.
Yeah, I was just going to say, I just looked at my notes. I remember, so I wrote mine as 3/2 times 79. 79 is all the bases. Anyways, ultimate answer?
3/2.
100. 124.5. It's velocity, so feet per second. Okay. So with a little guidance, you remember trapezoidal sum, yes? 2 more. Okay. The graph at the right shows the rate in gallons per hour at which stormwater is being pumped from an overflowing canal. Find the approximate number of gallons pumped from the canal in the 24-hour period. Okay. Generally speaking, what are we going to do here?
Area under the curve.
Area under the curve, that's our integral, right? I mean, officially, we're doing the integral from what to what? 0 to 24, because it's in a 24-hour period, 0 to 24. And officially, notice this is a graph of R of t. So I'm going to say it's the integral of R of t dt, right? That's generally speaking what we're doing. Now, they didn't tell us what R of t is, did they?
No.
They give us a graph. What are options?
Trapezoid.
Could we use a trapezoidal sum? Yeah. I think I heard the words Riemann sum.
Yeah.
Riemann sum would just be doing rectangles. You could do that as well. Trapezoidal is fresh in our head because we just did it on the previous page, right? So, you know, the note I have down here to myself is that you could use, they didn't give us direction here. So we could use a Riemann or trapezoidal sum. So just kind of good information to know there. Okay, so we're going to use trapezoidal. Well, we just talked about this on the previous page. Starts with 1/2. They all have the same width of 4, yes? Okay, so that means we'll do 1/2 times 4. Now, at 0, that's pretty obvious, yes? Let's go through and get some numbers here real quick. What do we have at 4?
125.
That's a 125, isn't it? Okay, so we have 100, we have 125. Okay, not so obvious.
140. 8. 140. Yeah. 135.
My notes say 135,
It looks more like 140.
but I kind of agree it looks like more like 140. Now, here's the thing. This is, what's the word I want?
Estimation.
Estimation. You know, when it's your point of view, you know, like,
Which is your.
I can't come up with the word I'm looking for, but now, here's what I'm going to tell you. I'm going to use 135 because that's the number I have in my notes, so that's the number I have the answer for. Does 140 make sense, though?
Yeah.
Totally okay with that, too. Okay, what's my next number?
130.
My key says I have 130 written down. Next number? See,
118.5.
117.
I have 110, which these numbers don't exactly go, but that's all right. This height is,
85.
I have 85. And
65.
65. Okay? Okay. Now, at that point, I wanted to get those numbers just so we'd be together, right? So, we have a single 100 plus two 125s plus two 135s plus 2 times 130 plus 2 times 110 plus 2 times 85 plus
65.
a single 65. A half of 4 is 2. Not what I have.
Dang it. I did it all in my head.
I know. That's why I was like, that's what I was waiting to see.
I didn't get it right.
You're usually my mental math person that at least tries it, so. I was just gonna. Hopefully Aiden will get what I have.
I mean, it was close. I had 2,800 total.
Okay.
I used 140.
Oh, did you use 140? Okay, so that makes sense that yours is off then. Okay. So here's mine. I have written down that it's 2 times 1,335, and then that's 2,670. Okay. So if you use any different, slightly different heights, your answer should be slightly different. Yes? Okay. And that would be 2,670 gallons. So that's just the difference of how to use the graph versus how to use the table as we did on the last problem. Okay. One more, maybe. I'm going to go the business route here. Find the cost to produce 50 widgets if the initial cost is 1,800 and C prime of X is given. Let X be the number of items of a widget produced. Let C of X be the cost to produce X widgets. C prime of X is called the marginal cost, which is the cost to produce one additional widget if currently X items are produced. And you'll notice it says that is C prime of X is equal to C of X plus 1 minus C of X. Okay. Okay, guys. So they want the cost to produce 50 widgets if the initial cost is 1,800. So, with that in mind, okay, guys, a couple of information. C prime of X, first of all, it's a derivative, so that is our rate, yes? It's also defined in there. C prime of X is called the marginal cost. So that is also defined in there as well. And I think, did we talk about that in, somewhere along the line I talked about marginal cost.
First semester.
Was it, okay, first semester. I was thinking Algebra 2 pre-calc, but no, that's right, it was first semester of calc. Okay, now, okay, what are we thinking we're going to do here?
1,800 plus C prime of X.
Okay. Yeah, and I pretty much, yeah, I have it written out differently, but that's exactly what we need to think is that there was the 1,800 plus the integral from, did you give me the time frame? 0 to 50 of, and I originally have a c prime of x dx, right? Now, the key is they told me c prime of x here, didn't they? So you're doing the integral from 0 to 50 of 155 minus 30x plus x squared dx.
Yep.
Huh. Interesting enough, I did this one by hand, but it is a calculator icon, isn't it?
Yeah.
Okay.
1800 plus the integral.
And we are about out of time, so.
Zero. 50. Yeah. Yeah.
Yeah.
What are you getting?
13,716.
Plus 18.
666.
136. Okay.
136.
30.
So yeah, I have those going to be 1,800 plus 11,916.6666667. Okay. Hey, I didn't just stop at 3 sixes. I gave extra. So you end up at $13,716.67, and that is the total cost for producing
50 widgets.
50 widgets.
50.
Isn't a widget just like a little doohickey? Like there's not the actual thing.
That entire sentence consisted of like non-things.
I know, because
A
it's not a real
doohickey
thing.
is, or a widget is a doohickey, but it's just a thing.
It is, I think. That's what a widget is.
I don't know if it's widgets. I mean, you have widgets on your phone,
Right.
but I don't know if a widget, widget has been around in math class before phones existed. So I don't know if a widget is an actual thing or if it's just a mathematical made up term of, kind of like doohickey, like,
Right. I think that's
is it an actual meaning or is it what it is? Okay, guys. So
Homer Dubin's.
8-3. Get it done. As I said, it shouldn't be too bad. It really shouldn't.
Test.
Test
Next
Wednesday.
No.